Welcome everyone to the class of marketing research and analysis. In our previous session we were discussing about factor analysis, and we had started with the exploratory factor analysis, right. So, we said that there are two types of factor analysis basically, largely speaking, the exploratory factor analysis and the confirmatory factor analysis, right. So, we discussed that factor analysis is used when a researcher wants to bring down a large number of variables into a few meaningful ones. So, it is basically a data reduction technique. So, data summarization, data reduction technique, which is used to bring in that a better explanation into the process, right. So, what accounts, how do we decide? So, we discussed about how do you decide the number of factors, right. So, we said it basically on two things, one is called the scree plot test, which is something similar to like this, right. So, if you look at the bends, at each bend, so each bend there is a factor, right. So, let us say, so this is the first factor, second factor, third factor, fourth factor, 5, 6 and 7, but we can see that most of the slope after this point up to 4, the slope is better, but after that the slope is slowly decreasing. So, the researcher has to take a call, this slope is basically the variance explained, right. So, the first factor explains the highest amount of variance, the second factor explains the second highest amount of variance, it goes on, right. So, the researcher has to decide at what cutoff that does he want to stop the process. For example, let us say by utilizing two techniques, the scree plot test and the Kaiser the eigenvalue method, we can decide upon the number of factors, or the basically today the softwares are built which are which conduct that, we do that exercise for you. But what is the, suppose let us say in a case there is a possibility that suppose there are there is a study where 90% of variance has been explained, right, through the factor analysis, and it has given you out of the 100 variables, let us say 12 factors or 14 factors. Now, 14 factors explaining, let us say something like this, 14 factors, 100 variables were there, okay, which came down to 14 factors, right. 100 variables were explaining 100%, 14 variables are explaining let us say 90%, right, let us say 90%. So, the 10% is remaining with the rest of the items, okay. Now, the question is, suppose I feel that, or the researcher feels that 14 is also too large a number. So, what you can do is you can fix the number of factors to let us say 6 or 7 or 8 or whatever is your number, you can decide, but when you reduce from 14 to 6, 7 or 8, what will happen is that the amount of variance explained by the factors will also reduce with it, right. Now, maybe 6 factors will explain only 70% or let us say 65%, anything, right. So, the cutoff value for the amount of variance explained in a social science study is at least 60%. So, we say if through the factor analysis you can determine at least 60% of the variance in the study, then that adequate number of factors should be taken into account, okay. So, if 6 factors, with 6 factors 100 variables, I am explaining the 100 variables, but only 60% I am explaining, it is still okay, okay. So, that decision has to be taken by the researcher, okay. So, second, we went through this, right. Now, when you are talking about the factor analysis, the inbuilt logic behind the factor analysis is the correlation, right. So, why we are saying the correlation? Because we are saying that there has to be a relationship among the variables, right. So, if there is a construct or there is a factor, the items within the factor, the variables within the factor are somewhere related, that means there is a correlation among the variables, right. But two different factors should not be correlated, the correlation between two different factors, two different F1 and F2 for example, should be poor. Why? Or the variables, let us say, that means what I am trying to say, let us say V1, V2, V3, let us say V4, V5, let us say, if I am doing this, what I am saying is, if factor 1, factor 2, suppose V5 let us say is is explaining in factor 1 and also in factor 2, we are saying that the variable should be loading good into one factor and not into the other, right. This is one of the basic assumptions that we make, and it is desirable also, because if it is loading on two different factors the same variable, then we cannot theoretically say ki whether this factor, this variable will actually be, should be considered into which factor, right. So, to avoid such a case which of cross loading, I will show you what, I will discuss what we have to do. Okay. So, now this is the correlation matrix which tells about these are different variables. Now, these variables, now suppose the first variable is itself related with 1, right. Second is with the second one it is 0.18 minus, right. Okay. Now, when it is a minus value, let us say sometimes you find a very significant high value, but it has a negative sign. What does it mean? It means that the variable is in the same factor, there is no doubt about it because of its high absolute value, but you have to reverse score it. Now, what is reverse score means? Now, suppose the highest value in that particular variable was 6, that automatically, suppose in a scale of 1 to 7 was, let us say 7, that should become 1, right. So, it has to be reverse scored so that this negative value will be taken care of, right. This is one thing. So, this is the initial statistics which says ki these are the variables and the commonality, the eigenvalue is given to you. Now, let us look at how it is explaining. The variance explained by the first factor, if you see, or the first is 40.7, then 24.9, it goes on, right. Now, how much are we saying, how at what point should we stop? The question is there, right. Now, we say that whenever the variance explained by an item or a variable is less than 10%, that means when it will be 10%, variance will be less than 10% when the correlation of the variable will be, let us say, above 0.3, is it not? Let us understand this, what does it mean? So, if two variables, if the R is equal to R, right, R is the correlation. If the R is equal to 0.3, that means the variance, which is the variance is equal to, at least we will say we can measure it through 0.3 square, right. So, we will say at least if we have a 0.3 square, that is 0.09 or 9%, right. So, to get a variance of more than 10%, at least the R value should be little higher, right. The loadings, basically the loading has to be little higher than 3. So, in factor analysis, the factor loadings that comes generally is those loadings are should be taken into account only which have a value of above at least 0.3, right. 0.3 is also is not a very stringent value. 0.3, let us say 0.5, if you take, it explains 25%, 5.5 square. So, to explain at least 50% of that into that factor, a particular variable explaining 50%, you need 0.7, that means 7 sevens are 49, 7 square, okay. So, one has to see that there has to be a good amount of correlation, right. So, this is basically what the values look like, right. So, the factor 1, factor 2, factor 3 up to factor 7, and the eigenvalues explained. Eigenvalues, I said in the last session, I explained that eigenvalues are the squared loadings of the different variables on a particular factor, right. So, so if I take the variables loadings, so the square, the sum of the square across, let us say this is F1 for the moment, let us understand, the sum is what we say is the eigenvalue, right. So, now eigenvalue and commonality also I had explained. So, commonality, if suppose if the researcher finds that the commonality there is a cross loading or there is a problem, he is unable to understand what to do. Suppose in such conditions, suppose a variable is cross loading, find out the variable which has the lowest commonality, right. Now, the variable which has the, because already eigenvalue has been taken care of in the software itself or the when you decide the number of factors, right, through the latent square we said. But suppose in your study you find there are some variables which give a very poor commonality of less than 0.5, let us say 0.5. So, if it is 0.5 less than 0.5, then it becomes an item for deletion, it becomes an item for deletion. So, suppose you see cross loading, that means a particular variable is cross loading into two factors, or you see that a certain variables are not being justifiably explained on basis of the theory. In such conditions, kindly look at the commonality value and check what is the commonality value, and the item which has the lowest commonality value is the item for deletion, right. So, you can remove that item, and but please you have to cross check it with the theory. If it is theoretically highly justified to stay in the study, then you should keep it, retain it, but suppose it is not that strong theoretically, then that particular variable should be an item for deletion because of its poor commonality value. Okay. Now, this is how it looks like. So, F1, F2, F3, these are the A, B, C, D, F, G, H, I's, all the different variables, right. So, coming up with 3 factors. Now, you see A contributing 0.6 into the first factor, 0.06 into F2 and 0.02 into F3, right. So, that means it is a variable loaded into the first factor, B into first factor, C first factor again, right. D is not in first factor, but it is in the second factor because the highest loading is in the second factor, E second factor, third F second factor again. Now, G is in the third factor, right, H third and I third, right. So, if you see now this 9 variables have been distributed across the 3 factors evenly, 3 3 3, right. This is a hypothetical example, and how much of commonality or the variance explained by the individual variables across the factors. Now, the total is for the first one A is 0.36, 36%, right. The second one is 67, which is a substantially good value, right. C is 60, 42, 65, 47, 50, 30 and 31. So, in case you feel, in case sometimes not in this study, but in certain studies you feel that a variable is not, because of a particular variable the amount of variance explained in the study is not being proper, or the variables are not fitting properly into the right factors. In such conditions, if you want to avoid or delete the situation, that particular variable, kindly go through the commonality. The one which has the lowest commonality is the one which is the right candidate for deletion. Okay. So, I have already explained this. Now, this is how a unrotated factor analysis factor matrix looks like. These are some 5 variables, right, and into 2 factors. So, these 2 factors, 3, all the 5 are let us say loaded here, and here these 2 are loaded because if you see what has happened now 0.63, 0.57, 0.49, 0.42, 0.42. So, these also do have a high value, it is not that they have a poor value, but most of the items are loaded into the first factor only, and this is a case when we do not rotate a factor. This is why the rotation of a factor comes into play. Now, if you do not rotate a factor, there is a possibility that most of the variables will load into the first or 1 or 2 factors, right. To avoid that situation, what we do is we rotate. So, suppose this is V1, V2, let us say V3, V4, V5, let us say these are the V6, let us say like this. So, if now I can say, let us say this is my F1, this is my F2, okay, F2. Now, that means what, in F2 let us say these are the ones which are coming, let us say this 2 and maybe this 2, right, and F1 only these 2 are coming, let us say. Now, if I rotate this, now what is happening is that possibly V1, V2 plus even V3 now comes into factor 1, right, and may even V6 can come, or otherwise V6 and V4 and 5 will come into the factor 2. So, this is an advantage that you get, and the nothing changes actually when you do a rotation of the factor, nothing changes as such. The variance explained in the study, everything remains the same, right. So, it is, you can see now 0.95, 0.9, 0.92 in the second factor, which was earlier not showing here, right, and now and these 2 are only the coming the rotated in the first factor. Okay. So, this clarity comes when you do a rotation of the factor. So, as I said, there are 2 types of rotations. The factor can be rotated orthogonally, or there is an oblique rotation. Orthogonal means is used when the factors are or the when we say that the factors are not correlated, the factors are not correlated. So, you can see for example, orthogonal factors are uncorrelated as it is written out here, you can see this uncorrelated, right, and oblique means factors are correlated. Although what happens in social science, when we make a construct, we say that each construct is sufficiently different from the other construct, right. There is a case of a discriminant validity, but the point is in social science, however you may say, there might be some relationship between the factors. For example, now if I say trust, satisfaction and let us say happiness are two different factors, but is it ever possible in the real life that satisfaction and actually happiness are not related? It is difficult, but the point is, to understand or explain the construct well, we assume that they are uncorrelated, and that assumption is what takes into the orthogonal rotation. On the other case, we have oblique rotation which says there is some correlation, but although we say that and it is maybe practically true also, but it is a complicated process of obtaining an oblique rotation, right. Orthogonal just says they are uncorrelated and there is a 90-degree between them, so it is uncorrelated, so that becomes more simpler and it is more widely used, okay. But in case you feel while conducting a research that suppose there is a cross loading showing on 2-3 variables, on 2-3 factors, then what you can do is you can go for orthogonal rotation, and in case you do not find any change in the cross loadings patterns, right, that means still the patterns of cross loading are being shown in the rotated factor also, then in that case kindly try to see and use other rotational methods, right, in oblique also, right. That means there could be a correlation, and maybe if you use that oblique rotation method, maybe the cross loadings will disappear, okay. So, there are different methods of orthogonal rotation, it is rigid 90 degrees as it is said, so the uncorrelated, right, and out of this the Variance rotation, if you can see, is the one which is highly used, right. What it does is it maximizes the sum of the variances of required loadings of the factor matrix, right. It is it works in the column columns, right, the distribution of the weights across the columns. Other matrices, for example, under orthogonal are the quatermax and the equimax, which are seldom used, which are not much utilized, because it works on basically the rows, right. It simplifies to ones and zeros in the row, right. Item loads on one factor, almost 0 on others. So, this is generally less utilized in comparison to the Varimax, which is on a column basis, right. So, and again as I said, the oblique rotation is the one where it could be less or more than 90 degrees, that means there is some correlation, it is not 90 degree, it is not there is not perpendicular to each other, right. So, these are some of the things that the researcher needs to understand. So, it provides a structure matrix of loadings and a pattern matrix of partial weights which to interpret. Now, the question there is, when you do a oblique rotation, there are two things that will come. Now, one is the structure matrix and a pattern matrix. Now, which one should you interpret? We will see, for example. Now, let us see an exact case. Now, for example, this is an orthogonal rotation which has been done. So, if you see, it is basically perpendicular as you can see, and these two are at a 90 degree to each other, okay, 90 degree, right. On the other hand, this is the oblique rotation where there is no the angle is not 90, so it is anything beyond or less than 90 or more than 90, okay. So, which one now should you use? So, many researchers have said, Nunali being a very popular researcher who has explained that orthogonal is more simpler, although it might not be very practical to I have many a times seen that oblique rotation gives better results, but orthogonal is still simpler to understand and get a better explanation, okay. And oblique can be actually misleading sometimes, yes, it is possible. So, many things we have out of this, some of the things we have discussed already. So, cross loadings are problematic. So, you need to understand what you want to do. As I told you, if there is a cross loading, that means one factor, then is one variable loading two factors, then you need to somewhere first it is an item for deletion, or else you can see ki whether theoretically that variable should go into which factor. So, that is completely a researcher's prerogative, or he could just delete those cross loadings by utilizing the different factor rotational methods. Okay. And finally, two things which are important are the factor analysis loadings of the summated scales, which I had earlier explained in the last session also, right. Okay. So, how do you do this? So, I am skipping these slides, I am getting into directly the one. Okay. From here we will talk about the using the FA results. Okay. This is very important. Till now we have understood how to create the factors, okay, and how to make the factors basically, right, on what basis you will make the factors. Now the question comes, we said it is an interdependence technique. The question is, can I use these factors? How will I use these factors? What is the basis or what is the methodology of using? So, in the last session also I told you that two things, one is called a factor score, right, and the other is called a summated scale, right. A summated scale was the nothing but the average of those variables across a particular respondent, right, for a particular factor. That means what? What do I mean by this when I am saying? I am saying that let us say when I want to do a summated scale, let us say this is factor 1 which has got V1, V2, V3, V4, and I said 5, 3, 4, 4. So, if I want to take a summated scale of factor 1, it will be like, for example, in case of respondent 1 it will be 5, 3, 8, 4, 2, 6, 4. So, respondent 2 it could be let us say 3, 2, 3, 4, 7, 9, 3, 12, 3. So, so it goes on, okay. And this value is a highly efficient and highly utilizable important value to us, okay. Okay. So, once you have this, right, once you get this, the factor the summated scale and the factor scores, then you can use this factor scores for your other studies in the regression and other things, right. So, I think now I have explained you enough to understand the exploratory factor analysis, the rationale behind the exploratory factor analysis, which is a correlation the correlation value, right, which is the basic underlying back the structure skeleton of this factor analysis. It is a regression model, but and it uses the correlation value also to explain itself. So, the question is, this is how we generated several factors out of a large number of possible variables, right. So, now the question comes, you can always go through these are later on, right, but the point is now what happens is there is a different kind of factor analysis also which is very important, right, and which we need to understand. Now, what is this factor analysis? So, in this factor analysis, instead of exploring, we will try to make a confirmatory study. Now, what is a confirmatory study? Now, we are saying ki we, as the word suggests, confirm, as I said, right, A and B. So, I know that let us say there are 3 variables V1, V2, V3. There are let us say 3 variables here. Let us say what I am doing is I am just changing like this. There are 6 variables in total, let us say V6, okay, and V3, V5 and V4 comes into let us say. Now, how did I do this? Now, this has come out of theory, right, and there is a this is basically a covariance model. That means both the variables are the construct is also a variable, right. So, if you have the construct, the summated scale of the you make it a summated scale, it becomes a typical variable, right. So, the question is, if I have this condition and I want to check the effect, or I want to even test a hypothesis or something, I can do it with the help of the confirmatory factor analysis. Now, let us see what is this confirmatory factor analysis. So, it uses something called a structural equation modeling. Now, to understand hypothesis, to test hypothesis, we use something, a confirmatory factor analysis method, a special case of confirmatory factor analysis, which is a SCM, right. So, what happens is it starts with a it is like a construct validation process. So, the construct is to be validated, and how do you validate the construct? Now, this construct is first of all a correct thing or not correct, is a valid construct or not. First you have to check that. To check that, we have different construct validation techniques. For example, we use convergent validity, discriminant validity, nomological validity, several validity things, right, out of which the convergent and the discriminant validity are the most popular ones. Okay. SCM is used, right. So, it basically starts with a correlation matrix, as I have said always that a covariance is also a correlation, right. In our earlier classes we have discussed, but a correlation may not be a covariance. Why? Because a correlation is a standardized covariance basically, right. So, that has to be remembered, right. Now, this is how a confirmatory factor model looks like. So, there is a clear, if you can see x1, x2, x3, x4, x5, x6, x7. Now, we know that these relationships are very clear, the researcher is aware of it, right. So, and these are basically the error terms which is taken into account, which is taken in an exploratory factor analysis, those errors were ignored, but in the case of a confirmatory factor analysis the errors are taken into account, and we also feel that there is a possible relationship among the residuals or the errors. Why? Because they are nothing but the unexplained variances. So, these unexplained variances could also have a relationship among themselves, right. So, this is how this is an example, right. So, you can see that these constructs have their own variables, some are shared, but some are unique. Okay. 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 This is a I would like to, for people, this is let me just brief the confirmatory factor analysis and then explain. In fact, what I have done is I have created a slide to tell you the steps, how to make the steps in factor analysis. So, here I have just explained that part. So, there are few steps. First step is to develop the correlation matrix, any factor analysis. There is something called a Bartlett's test of sphericity. In fact, why I have kept this slide, in fact I remember now, because I thought ki you might although I am teaching the theory behind it, you should also remember the steps to be followed, right. So, to understand that, first is when you do a factor analysis, what you should do is basically the exploratory we are talking about. So, what we do basically is that we try to find the correlation matrix among the variables. Second is we try to understand ki whether there is some correlation existing in the variables or not, and that is done through a Bartlett's test, which is the one which I was saying in the last session also, that there should be the loadings. That means Bartlett's test, when you say the value should be less than 0.05, that means if it is less than 0.05, that means the null hypothesis would be rejected, the null hypothesis being that there is no correlation between the variables, right. So, that is the second step. And there is something called a KMO is basically what is used, KMO value of 0.7 around we take, 0.5 is the cutoff value. So, we say that if whether the number of sample that you are using is justified, is good enough to explain the factor or not, that can be known through a KMO study. The KMO value, if you find any SPSS software, you can see that the KMO value basically tells if it is above 0.5, that means there is a sampling adequacy, that means the number of samples used are good enough, but a very high value like 0.8 or 0.7 is much better, are great, right. So, third is the factor rotation extraction, which I always said, right, I have explained. Then we did we explained the variance. So, this is the how you understand the variance. So, the first there are 10 variables, there are 3 factors emerged, and these 3 factors I have explained 58.56, okay. And this is how also you find out through a graphical, I explained that, okay. So, these are the 3 factors, this is a I think it is good to see one example. These are the variables. For example, you see I discussed my frustration feeling with persons in schools, I try to develop a step by step action. So, all these things, all these are loaded into 3 different factors. The first factor has got 1, 2, 3, right. Then how How do you know this? Now you can just look at the values, highest is here, right, in the 3, then this one is the second highest, right, but this is a sign of cross loading, okay. Third is this one again, fourth is this one again, but again you see they are very close to each other, right. So this is how you decide ki which variable goes into which loading, which factor. So then you do the factor rotation, and after factor rotation through orthogonal or whatever, now the same result has been redistributed. You can see, you can compare it, and you can find that now the cross loadings are minimized, cross loadings are minimized. If you see in second, for example, if you look at this, so there was a cross loading in the second case, right. Now let us look it here. Now it is very clear ki this is the one, it has now moved into the third factor, okay. So this is what it does. And fourth step is to make the you interpret, you name the factors, right, and you do it. Now this was what I had prepared, but now what I will do is maybe I have just explained you today the exploratory factor analysis only, and I have just briefed ki what is a confirmatory, and then I again showed you a table. So this table was to explain you the how to conduct the factor analysis. You can when you see these slides later on also, you can go step by step and understand ki what exactly is to be done and how to utilize these factors later on for other purposes or other studies, right, which is of high importance, okay. So well, this is for the session. What I will do is in the next session maybe I will carry on with the second part, confirmatory factor analysis and structural equation modeling, right. So structural equation modeling is a special case of a confirmatory factor analysis only. So it is a part of the factor analysis. So where we will try to test hypothesis, right. In a exploratory factor analysis we are unable to do test hypothesis. So in a XCM or a path analysis we will try to test a hypothesis also with the help of with the study, right. So that we will do in the next coming session, and I think today what we have done is an introduction or a beginning into the factor analysis, and I am sure you are very clear with it, and you can just go through and browse through the terms that I have explained, and if there is something we can maybe we can talk about it. So the point is please remember these are very important terms. What are, like for example I said summated scale, factor scores, factor loadings, rotation, orthogonal rotation, oblique rotation, then all these values, all these different concept and terms are very important, and one needs to be very clear with it. And please remember one thing, never ever always when you do a factor analysis it has to be on the variables, and these variables are basically variables measured in a continuous scale, right, on an interval scale for that, right. So this is what we have for this session. We will meet in the next session with confirmatory factor analysis and SCM. Thank you so much.